Hey, David Rafloff here with the video on refactoring. This one's going to be about extracting a class. I was working on code for a game, trying to add some features, and realized I had a class that was kind of getting out of control. I noticed that it was stacking up a bunch of methods that weren't directly related to what the class was about, and that those methods were similar in structure to each other. And that's a good sign that you're doing essentially like an if statements, more or less, like you're switching on what should happen, um, and depending on which thing's happening, you know run a block of code. But if you have a couple of these blocks, two or three of these blocks that basically start to look the same, um, that's a good sign that you probably have like some objects there that are conforming to the same structure and the same interface, and that there's an opportunity to just pull those things out. Um, if you're able to do that too, like and have those be very consistent, one thing that can do is let you use what's called like the strategy pattern, where you basically just, depending on the thing that's happening or the type of thing you're dealing with, you just pick the strategy and then just tell the strategy like this is what I want to do. Um, so anyway, it's kind of a nice thing to keep an eye out for. And I'm just going to run through an example of that here real quick. I'm not quite there on the strategy part of this quite yet, but getting closer. I can kind of show you what that looks like. So initially I had this interactor class here, and you'll notice it's an interactor for a player right here. And the idea is that in my Unity game, my player is going to run into something, and whatever it runs into is going to also have an interactor. And based on what it's running into, or what type that interactor it is, what kind of thing that interactor is for, it's going to try to figure out what to do. So right here, I'm actually just looking at the commit I'm getting ready to do. And you can see some of the stuff here in, I'm trying to find it, in red, is I had these two methods going on that were like handle attack and handle health given an attribute. So you notice they're both taking the same arguments of the same type, which is already kind of an indication that they've got a similar structure or function. And then you'll notice here in both of them, the first couple lines of code are more or less the same with some slight variation. So if it doesn't get an attribute, it just wants to return and do nothing. If it does get an attribute, it's trying to get to the value of that. And you'll notice it's this one's basically just flipping the sign on that. So that's like gaining health versus getting attacked or losing health. And then after that, they both call change health on attributes. And then here, I'd already added this new line, which was basically when my character gets hit, I want a little indication that the health is changing to like float up from the top of the character's head. So like plus 50 health or minus 50 health or whatever. And I'd already added it here. And then I realized, well, I'm just adding that again down here. So that's when I kind of realized, hey, these things are just going to be doing pretty much the same thing with some slight variation. And I didn't want to keep adding to those. This class is really about interactions, not about how to react to what's happening. And you'll notice here the calls are really similar for each of these cases. So if the interactor is a stimulant, I would just call it handle health. But also, if it was anything else, which at this point would just be attacks, it calls handle attack with that attribute, and then just pops out of there. So anyway, didn't want to keep adding to that. So what I did instead, the other thing that I was running into was I needed a bunch of little like private helper methods to clean up some of this stuff, like this line. And I noticed I was just adding a bunch of private methods to a class that wasn't really where I wanted to add them. So anyway, there were a lot of little steps along the way, but basically what I did was I extracted this reactions namespace. This should probably be player reactions. But anyway, it keeps track of an attributes, something that conforms to the attributes interface, and then keeps track of an attribute name. This was just a little convenience thing for something we'll get down to later. But so this is kind of standing in for what was the handle health method that took attributes. So now it's an instance of this class will take attributes, and we'll just hold on to it. And then I went ahead and provided some default behavior here, but really this should probably be emptied out. But by default, it's just doing whatever the health method was doing previously. So returns if there's no attribute. If there is, it looks at the value. If it's 0, it returns. Otherwise, it's going to call change health with that amount, emit that little text thing, bit of text above the player's head, and then just return whatever the value was that it came up with. And then have some little private helper methods down here. So emit text takes care of formatting that string. So like if it's healing, the string is going to be like plus, say 50, and then energy, because that's the attribute that we're dealing with. And then there's some more little helper methods down here to sort that out. So when we're dealing with health, we don't invert the sign or the amount. So that's just going to return the value is just going to return the exact same amount. The sign, if it's positive, is going to return plus, and if it's not, it's going to return minus. And then whether it's positive or not, when you're healing, positive just means any value greater than 0. But again, all these, I can probably clear out a lot of this public method here and move that stuff over to healed, because it's not really universal. So I should probably do that. But then you can see the classes that derive from base. So now we have a healed reaction class, and that all that really has to do is call the base class, because the base class is set up to essentially do what healed was doing. Again, I could just move all that code over to here. And then attacked, doing something slightly different. So we want to kind of invert or make the amount negative here. So if you're attacked for 50, that actually needs to be considered like negative 50 towards your health. So we just have to redefine this one little private method. But then with just that small change, now we get the flexibility that we want. And when we look back at the interactor, all we have to do is, for the different cases, we just call the right reaction that we want. And we're calling them with the same values. And we're just changing it, what the reactor is based on the situation. So it's kind of like a strategy. If I was to change this one to say like an exited reaction with the react method and move this into that object, then the code I'm calling here would essentially be the same for each of these cases, with the exception of this line, which could handle some other way. But the nice thing there is then you could move this switch out into a method that basically just for each type gives you the right reaction, and then once you get the reaction, you just always call react. You don't have to like have special cases for how you deal with the code for each of these branches. You just say, here's the kind of interactor I have. What kind of reaction should I have based off of that type? And then just give me that reaction, and then I'll execute that reaction essentially with the same arguments regardless of what the type of the reaction is. And that's cool because that's really flexible, and you can just swap out reactions as you need to. So anyway, just wanted to do a quick little video on how that works, and thanks for watching, and I'll probably do another one like this. So I want to take this all the way and actually implement the full strategy kind of pattern for this. So anyway, thanks for watching, and I'll see you in the next one.